We are all aware that the planets in our solar system rotate around the sun, and they will continue to do so for an extended period of time. When ancient astronomers first began to understand the motion of planets as seen from Earth, they came to believe in a form of harmony, a perfect balanced dance among the planets known as the harmony of the spheres. For example, Copernicus believed that the planets revolved around the sun in round orbits. However, Johannes Kepler's cosmology was heavily influenced by his belief in planetary harmony. Kepler goes beyond Copernicus' static model of round spheres and proposes a dynamic one. He turns the planets' orbits into ellipses as they move at different speeds. He assigns to each planet not a single sound, but an interval in which the lowest note corresponds to the minimum velocity and the highest to the greatest. This immaculate equilibrium, this harmony of the spheres appears immutable. If you could leave the solar system and return in around 1,000,000 years, you wouldn't anticipate anything to have changed. So while it is extremely unlikely that something catastrophic would occur, but what if it did? What if, for example, Mars hits the Earth? Follow space-time and join me on this adventure as I investigate this terrible yet intriguing idea. I'll walk you through the ideas and simulations that scientists use to answer this topic. Learn about what could happen and how, as well as the risks associated with such an incident. Consider how we may preserve the Earth from such disaster. Mars and Earth colliding may appear unlikely at first because their orbits around the sun are so different. According to the video's host Gabe Perez Giz, the gravitational forces exerted by other planets in the solar system can likewise affect Earth and Mars. Now those extra tugs are insignificant. However, if everything aligns perfectly, over billions of years, they might have a significant cumulative influence and deform the orbits. To understand what might happen and how, scientists must perform a series of simulations that account for a wide range of physics and take into account specific constraints. In one of the simulations, they chose to slightly disturb the harmony of the spheres. They just moved Mercury away by 1 meter. Then they rose from their seats and went to make some coffee. When they returned, the simulations over billions of years revealed that, in this scenario, the orbits of the other planets had extended out due to Mercury's new location. This led Earth's orbit around the Sun, Venus, and Mars to widen. The scientists subsequently discovered that Earth's revised trajectory will result in a direct collision with Mars in 4 billion years. This was both fantastic and disturbing. Here's why. If Mars collides with Earth, the results will be catastrophic. The impact would result in tremendous damage on an unimaginable scale. The collision would be extremely powerful, causing major earthquakes and tsunamis throughout the Earth, as well as earthquakes and volcanic activity. These calamities have the potential to produce a global catastrophe, destroying populations and cities with severe volcanic eruptions, tsunamis, and earthquakes. The Earth would be enveloped in a firestorm of gas, dust, and debris, causing temperatures to rise dramatically, resulting in a global climate shift and catastrophic weather patterns. The impact would release a large quantity of energy, killing thousands and leaving millions homeless. In the aftermath, the shockwave and accompanying energy broadcast would spread in all directions, causing a global famine by destroying crops, cattle, and other supplies. The Earth's infrastructure and vegetation would be devastated. Such a catastrophe would have long-term consequences for humanity as we know it. Rebuilding would be difficult, and it could take generations before the Earth returns to normalcy. Furthermore, the radiation and rising temperatures would cause ecological devastation, potentially leading to the extinction of some species as a result of the huge destruction. If you were able to escape in a starship following the impact, you would watch the huge fragments of both planets flung into various orbits. Some would strike other planets, while others would be launched out of the solar system entirely. Whatever was left would form a new asteroid belt around the Sun. Nothing would indicate that there was once intelligent life on Earth. And you, I, and everyone you know would be gone forever. Perhaps no sentient alien life would be aware that we were present in the universe at some point in its past. But what's really remarkable is that astrophysicists are almost certain a comparable event occurred in the distant past. It also generated the Moon, our magnificent satellite. The so-called giant impact theory argues that the moon arose as a result of a collision between the Earth and another tiny planet approximately Mars size. The debris from this hit accumulated in an orbit around Earth, forming the moon. Some evidence supports this view. For example, when the rock samples from the Apollo expedition returned, they revealed that the Earth and the moon share some amazing chemical and isotopic similarities, implying that they have a shared history. The scenario considers the proto-Earth and Theia, a planet roughly the size of Mars. According to the giant impact model, these two bodies collided sometime during Earth's early history. During this catastrophic collision, nearly all of Earth and Theia melted and reformed into a single entity, with a little portion of the new mass spinning off to become the moon we know. Scientists have tried with modeling the impact, varying the size of Theia to see what happens at different sizes and impact angles and attempting to find the closest match. Earth and Theia were made of nearly identical components to begin with since they were in the same region when the solar system formed. If the two bodies originated in the same location and were constructed of similar materials, this would explain their similar composition as revealed by Apollo mission samples. This new movie from NASA showcases the most detailed simulation ever created to reproduce the early and post-impact circumstances of the giant impact scenario. This simulation suggests that the moon might have formed in a matter of hours when material from the Earth and a Mars-sized planet was sent immediately into orbit following the impact. The simulations utilized in this work are among the most detailed of their kind, with the highest resolution of any simulation done to investigate the origins of the moon or other massive impacts. Are you still here? If so, it means you're thoroughly enjoying this video. So why not subscribe to the channel and click the notification bell? To avoid the terrifying situation of Mars colliding with Earth, the planet's orbits around the Sun must be perfectly balanced. If all planets are perfectly aligned and sufficiently separated, the possibility of an impact is removed. This balance must be maintained so that the solar system may function harmoniously, with each planet moving in a predictable manner and keeping its orbit as intended. Keeping the planets in perfect harmony is critical for the existence of life on Earth and the overall health of the solar system. With the right balance of planets, the solar system will stay stable and secure, as will life on Earth. The main issue is that gravity is extremely sensitive to even minor alterations. We've previously seen it with Mercury, but engineers and dynamicists are also extremely familiar with it. In principle, if we know the current state of a system, we may forecast what it was like in the past and how it will act in the future. But this is only in theory. In practice, we use computers and do simulations. And computers aren't perfect. Every computation on a computer will contain some errors. Of course, the smaller the better, but our computations will never be perfect, and over billions of years, a minor inaccuracy could propagate and produce different outcomes. If Mercury was only relocated by a fraction of a meter, it would result in a cataclysmic disaster lasting billions of years. The same thing happens with artificial satellites orbiting the Earth. That is why engineers require correction maneuvers to keep them in the correct orbits around the Earth or its Lagrangian points. There are methods for this, but they are extremely difficult to implement. There is extensive research underway to secure the stability of these orbits. To summarize, the prospect of a collision between Earth and Mars is a scary truth, but it is critical that the harmony of the spheres be maintained by keeping the planets in perfect equilibrium in order to avoid this tragedy. Humanity must also defend our planet by doing all possible to keep our solar system in perfect equilibrium. This will contribute to the sustainability of life on Earth and the stability of our solar system. Alright folks, that is all for this video. Thanks for watching. Is there anything you'd like to say? Please let us know in the comments below and remember to like, share, and subscribe.